Okay, so the next problem in the lead code we are solving is lowest common ancestor of a binary tree. Okay, here we have given the binary tree, and what we need to do is we have to find out the common ancestor. Okay, what does it mean? Let's see. So P and Q has been given. P is equal to 5, Q is equal to 1. So P is 5, 5 is here, 1 is here. These are the two P and Q. What is the parent for this one? 3. That is the answer. Okay, and now let's say that we have been asked for, let's say that other example. Okay, this was an example. Okay, now let's say that we'll take an example of 6 and which are 4. Okay, which is the parent common parent for this? Obviously 3, correct. 3 is always the common parent, but what is being asked here is lowest common ancestor. So what does it mean? We'll have to find out the nearest parent that is common to the both. So should we check 2? Okay, let's check the 2. 2 is parent of this one, right? But this is not a parent for 6 one, so we cannot consider this one. Okay, and finally, like when we go to here, right, when we check for 5, 4 is parent for this one, and 6 is also parent for this one. So it means this is our answer. So this is the lowest common ancestor for a given nodes 6 and 4. Okay, this is the problem. Okay, now let's see that how we are going to solve it. So let's break down this problem. Okay, so let's say that we'll take only this part now, this part for now, and let's say that for in the given problem what is being told, 5 and 1. Okay, so what I'm going to do is I'm going to do a calculation. So when doing the calculation, I will ask my child node, left child node and right child node to see, like, I mean, if you find this guy is P and Q. Okay, I will be sending 5 comma 1 here, 5 comma 1 here, and I will be sending 5 comma 1 here as well. Okay, and what these guys will do is they will check for themselves if their value is matching with themselves, if the value, if it is matching with a P, or if it is the value matching with a Q. If it matches, it will send back the result saying that true or false. If it matches, it will return true. It will else it will return false. So again, same thing will happen here, true or false. So let's say that 5 will be matching to P, it will return also true, and this will match with 1, this will also return true. So it means that, okay, left also is matching, right also it's matching. It means that this itself is a parent, right? Like, because I asked him to find out these two, this will be the nearest possible thing, correct? So this will be our answer, like, I mean, okay, this will be the common ancestor, we'll be returning this value. Okay, now let's try to expand this problem. Okay, so now let's take the other example which we discussed, which is 6 and 4. Okay, so we'll start from here only. Okay, what we'll do is we'll do the same, apply same logic whatever discussed so far. I will ask this guy to find 5 comma 1, 5 and 1. Okay, I will ask this guy, sorry, in this time it is 6 and 4, right? The example is changed now, 6 comma 4. I will ask this guy to check 6 comma 4. He will say that he will compare within himself. Okay, he will check it, it is not right, like, I mean, it is not matching with 6 or 4. So what this guy will do now, he will ask his child to check compare with the 6 and 4. Again he will send 6 comma 4, and this time what will happen, it will match. So he will say that I have a match, brother. So it will say that it is a match, so it will return a true here. Okay, so, and also we need to wait for the left, right also, right? We found this one here, we'll also ask, we should ask the right tree also always. So you will ask, you will send 6 comma 4, it's not a match. So again this guy will ask these two guys, these two children, 6 and 4. So this guy finally will match it with this. So he will tell this is the match, I have found a match, so I will return a true. So okay, so ultimately what's happening here is, so if either of them is matching, it means that we have something there, right? So we'll be returning the true. Okay, bro, I found some value. Okay, I found some value here. Okay, but here this guy returned a false. Okay, right? I didn't find any, but this guy returned a true, right? So ultimately what this guy this guy needed, if you found 6 or 4. Okay, so ultimately these nodes will return that I found 4. Okay, we'll be returning the node value actually. So okay, we'll be returning the 4, 4 finally here. I was just to simplify it, I was explaining it as a true, but ultimately we'll be return either of them, right? Like, I mean, we can return true, or we can actually just send the value itself, right? Ultimately, like, we will check if this is a if the value exists, we'll be considering it as a true, else it is a false, right? So ultimately what happened just happened here. So this guy sent a request to these two guys. Ultimately he got a response from both the nodes this time. So it's a true and true. So as we discussed before, when we got a result from both of them, it means that is the ancestor, correct? I've asked the two childs to find these two childs, both of them return true. It means that I am the common ancestor. So I will be returning back this answer that um, I myself is the common ancestor, that has a 5. Okay, we'll send it back as a 5. The answer will be ultimately resulted in a 5. Why it will be resulted in a 5? Because all these nodes will be returning the false, because when we check for P and Q, right, 6 comma 4, nowhere will found, we will return a false. So at this time what we'll do is we'll return the left, whatever that is left, return in the left. Okay, now quickly check the solution, if you have understood the so far. Okay, so if there is nothing, we'll write some base condition, return none. And we'll here, whenever we got a node, what we'll do, we'll check if this is equal to P or equal to Q. right? If it either of them is matching, we will say that okay bro, we found a match, this is a match, okay, whatever the value that is there, this is a match. Okay, okay, let's check this later. Actually, we'll ask the left tree actually if we found it. Oh, actually, okay, yeah, this we need to analyze. Let's say that this is the only one node we have, right? So that's what they are doing, trying to do actually, three. Okay, that will return it. And let's say that we'll also have to ask the left childs and right childs. If let's say that if both return the true, it means that I am the parent, so I'll be returning this as my answer. Let's say that if either one of them is returned, we'll be returning either one of them. Yeah, ultimately we'll be getting the solution there, right? Like if both has returned it, this will be our answer, so it will be carry forward. And ultimately let's say that the left lca returned a true for this one, but here it has returned empty. So it has returned an empty. So what will happen? So ultimately this will be picked up because left lca or right lca, right, it will be picked up and this will be returned as a result. That's it. Thanks.